Hello friends, welcome to G-Centric. So in this lecture we will see the next question which was asked in GATE electrical branch in 2014. So the voltage across the capacitor is expressed as Vc of t. Okay, so it have given A1 sin omega 1 t theta 1 minus theta 1 plus A2 sin omega 2 t plus theta 2. Okay, so here will be some value theta 2. So if they have given us this circuit, capacitor is here, we have to find the voltage across this capacitor. So they have asked for the values of A1 and A2. Okay, and they have given 4 options. Now if you observe both the sources, voltage source as well as the current source, then both the frequencies are different. Okay, here we have 10 and here we have 5. So in the previous lecture we have seen that if there are two different frequencies, then we have to compulsory use superposition theorem, right? So first we will take this source. Okay, so we will consider the voltage source first. We will open circuit the current source. Okay, so when we remove this one, when there is no connection between this branch, then 0 ampere current will flow through the inductor. Okay, so we have only voltage source, resistor which is of 1 ohm, and we have capacitor of 1 farad. Okay, so first we will convert this into phasor. Okay, so how we will convert it into phasor? You will divide it by root 2. Since both are sine values, I will take the reference as 0 degrees. Okay, so now we can calculate, and also we have to convert the capacitor into ohmic value. So how we will convert this one? Xc is nothing but minus j over omega c, and for this source omega is 10. So 10 into c value is 1. So it is minus j.1. Okay, so now since only voltage source is there and these two are there, we can apply voltage division rule, which comes out to be Vc1 equal to, so for finding the voltage we have to take the same capacitor, same resistor or capacitor, okay, which we want to calculate the value of it. Okay, so Vc1 will be equal to its ohmic value, that is minus j.1 divided by total impedance, that is 1 minus j.1 into total voltage. So we have to take in the phasor value. Okay, 0 degrees. Now we will keep this as it is. This will become 0.1 into 90 degrees. This is into 20 angle 0 degree. Okay, root 2 we will keep as it is and also multiply in numerator and denominator. So it comes out to be just 2. Okay, so this cancels out with this one. So you will get it here as 10. Now for this one we can calculate under root of 1 plus 1 square plus 0.1 whole square, and for the angle it is tan inverse of minus 0.1 divided by 1. Okay, so now this total value Vc1 comes out to be, it is root 2 minus 84.29 degree volts. Okay, so this is in phasor. We do not want it in phasor value. We have to take in the RMS. So we have divided this as divided by root 2. So to get back that, we will multiply this by root 2. So we will get Vc1 is equal to 2 into, so what was the reference? We had taken as sine at an angle 0 degree. So it will be 2 sine, frequency will be same, 10t minus 84.29 volts. Okay, so this is Vc1, right? So now here from this one we have got Vc1. How much is that Vc1? It's nothing but A1, alright, which is in the form of sine, and here also it is sine, right? So we have to take only this value, amplitude. Okay, 2. A indicates the amplitude here. So when we have 2 here in the option, so B and T will cancel. Okay, so now we have to compare with the A2 values. Okay, so now we will take this source, this current source. Okay, one value we have got while opening the current source. For the second value we will short circuit the voltage source. Okay, so we will short circuit this one, then we will join this open circuit. Okay, so here same thing, we will take the value of in angles, so both are sine, we will take the reference here as 0 degrees. Now there will be some amount of current flowing here, right? So here also there will be some amount of current flowing. Now we have to take the ohmic values of the inductor as well as the capacitor. Okay, so we will take that XL is nothing but omega L. Okay, so when XL is omega L, omega is 5, we have to take this frequency and this is into 1. So this is J5. Okay, so now we have XC also, it will also change. Here J omega L minus J omega C. So minus J omega is 5 and Henry is minus J 5. So how much you will get? It will be 1 by 5 will be 0.2 minus J. Right, so I'll write these values here. XL is J5, XC is minus J.2 ohms. Okay, I'll rub this. So now we can apply the current division rule. Okay, so either you can apply here or the same current will flow through this inductor also. Okay, so it will be same 10 sine 5t. So here from here you can apply the current division rule. So for applying the current division rule, we have to take the opposite element if we have to calculate for this element, right? So for I current 1 farad, we will take it as 1 ohm divided by 1 minus J 0.2 into total current. Total current is 10 by root 2 angle 0 degree. So here also we will multiply and divide by root 2, you will get 5 angle 0 degree. This is 1 square plus 0.2 square tan inverse of minus 0.2 divided by 1. So overall you will get this value as, that is we have to calculate, okay, I will just keep this as it is, we have to calculate VC2 also, right. So VC2 is nothing but 1 angle farad into its ohmic value minus J 0.2. So substitute this one current of 1 farad here, you will get 5 angle 0 degree. So this is root 1 square 0.2 whole square. So tan inverse, okay, so this is into minus J 0.2. So this VC2 you will get it as approximately 1.96 sine, that is 5t minus 78.7 degree. Okay, you can calculate it with the help of calci, you will get this angle. Take it to the numerator, from the denominator it will become minus. Okay, so approximately we got the A2 as 1.96. Okay, so the nearest option is 1.98. Alright, so this option also gets cancelled. So 4.20 is very far away, it cannot be approximated. So our answer is A. Alright, so it's nothing but whenever the voltage source is given and whenever we have got two different types of frequencies, then we have to apply superposition theorem. Okay. So this was about how you can solve. So it's all on the basic concept, and one more rule we have to remember is that in AC analysis, if the capacitor and inductor values are given in Henry or Farad, we have to convert them to ohmic values. Okay. So one more question we will take where we will cover all the concept. So since here the calci was required, which was allowed in 2014. Okay, so that's why it was complicated. Otherwise nowadays the questions of the gate questions will be asked without the help of calci. You can calculate very easily. Okay, so we will take up the next problem where we can see complete theory that we have learnt in the superposition theorem. Okay, so coming to this 8th question, we have given a circuit, okay, where there are two voltage sources. Okay, they have observed that they again have different frequencies, and here we also have different sine and cos. Okay, so we have 1 ohm resistor and 1 millihenry with a DC voltage source. So we have to find these 4 parameters from the circuit. First one is expression for I of t, Then we have to find this ammeter reading. So this ammeter reading, what type of current does it measure? Average or maximum or RMS? It is RMS current. Okay, so we have to, from this expression we have to find IRMS. Okay, so next we have to see the power consumed by the circuit. So which element consumes the power? Okay, we have got two elements, resistor and inductor. So power is consumed by the resistor. Inductor will not consume the power. Okay, so it's a storing element. So from this formula, from this third one, we can either use I square RMS into R, or we can use one more formula also, that is VRMS into IRMS into cos phi. And the fourth one, we have to find the power factor, that is cos phi. So we will see what formula we can apply here in the power factor. Okay, so first we will solve for the expression of IT. Okay, so I'll first take the DC voltage source 5 volt. Okay, so what it will be, all this will be short circuited. Okay, here it is short, then we have got 5 volt. Ammeter is also a short circuited, okay, because it's just a reading that we have to take. And what will be inductor in the DC, when DC will be given for the inductor, it will be short circuit, it behaves like a short circuit. So we have seen that in the properties of the inductor. Okay, here we have got 5 volt and here it is 1 ohm. So how do you calculate the current? I1, it is very easy, that is total voltage in this circuit upon impedance. We do not have any impedance, we have only one resistor. So it comes out to be 5 amperes. Okay, so here for the first one, I'll write I1 is equal to 5 amperes. Coming to the second one, so this DC will get short circuited, I will take this one. Okay, so now to calculate that one, I'll convert, for the conversion of phase, what we have to do in phasor domain, you have to divide by root 2. So this root 2 gets cancelled and I am left with 10. Okay, so it is in sine and here it is in cos. Okay, so if I have to convert this to the cos, I have to take this angle minus 90 degrees. Okay, so 1045 minus 90 degrees, which comes out to be for the 10 minus 45 degree angle. So for this also we will divide it by root 2. So it comes out to be 100 angle 0 degrees, right? Because we have taken this cos as the reference. Okay, so we are converting this sign in terms of cos. Alright, so first now we will consider this one, which is the 10 root 2 sine 1000 t plus 45 degrees. So we will consider this source. So we will having this source. Okay, so here it is short circuit. This is also short circuited, but inductor this time it will not be short circuited. Okay, so now convert that into ohmic value. So XL j omega L. So what is the frequency we are taking? It is 1000 into, we have 1 millihenry. So 10 to the power minus 3, it comes out to be 1 J. Okay, so I'll write it here as J1, this is 1 ohm. Okay, so now we have this one. What is the value of this? It is 10 angle minus 45 degree. Okay, so now I will take the I2 10 angle minus 45 degree over total impedance, that is 1 plus J1. So this I2 value comes out to be 10 by root 2 minus 90 degrees. Okay, so this is the value of I2. Okay, I'll write it here. I2 is equal to 10 by root 2 minus 90 degrees. Alright, so this is how you calculate. Next, I will take this source as active source. Okay, so that is 100 root 2 cos 3000 t. Okay, so this I will change it. It comes out to be 100 into 0 degree volts. Okay, this will change. Okay, as the frequency changes, the ohmic value of the inductor will also change. So XL is equal to nothing but j omega L J will keep as it is. What is the frequency? 3000. Okay, 3 into 10 to the power 3 into 10 power minus 3. So it is 3J. Okay, so here I will take the current I3. Okay, I will take the current I3. So I3 is again 100 total voltage upon impedance 1 plus 3J. So this I3 comes out to be 31.64 angle 71 minus 51 amperes. Okay, so now we have got I1, I2, I3 due to the 3 sources. So now I can rub all this and I will take the I net. Okay, so after completing the superposition for each of the active sources, okay, I have got 3 values I1, I2 and I3. So I will add them together, I1 plus I2 plus I3. So I1 is 5 and here I2 is root 2 minus 90, then this is 31.64. Angle is minus 71.51. Okay, so this is the I net. Now if I have to get the value of I of t, okay, so this is I net, but I have to convert this phasor domain to time domain. Okay, so if I have to get I of t, so there will be no effect on the DC value, so I will keep as it is. For this one I have to multiply root 2 because I have divided by root 2 in converting the phasor into the phasor diagram. Okay, so when I do it root 2 gets cancelled and I will be left with 10. So for this one, since I will take the reference as cos, okay, so we do not need to again write it as theta minus 90 degree because since it is given here sine, it is not compulsory here to do it as minus 90 degree again. Okay, you can directly take in terms of cos. So this comes out to be cos 1000t minus, so this is 1000t minus 90 plus here also 31.64 into root 2 because you have divided this by root 2. So we have 3000t minus 71.51 amperes. Okay, so this is the answer for our first question. Okay, so this will be the expression of IT. So coming to the second one, that is ammeter. So for the ammeter reading, it will always measure IRMS. So from this one you have to take the IRMS. So we know how to calculate the IRMS. It is nothing but under root of 5 square 10 by root 2 whole square. Okay, so this also we have to divide by root 2. Here it gets cancelled. So it will be 31.64 whole square. So for the answer of this one, you will get it as 32.80 amperes. Okay, this is approximate value for the IRMS. Just know the way how you can calculate this one. Okay, so this is nothing but we will take all the amplitude and divide them by root 2 except for the DC value. Okay, and we will square for each of the terms. So we will get the IRMS. Okay, so this solves our second question. Coming to the third one. So power consumed, we can either use VRMS, IRMS into cos 5 or we can use I square RMS cos 5. Since we have IRMS already here, we will use this one. So we will avoid calculating VRMS. Okay, so I square RMS is nothing but 32.80 whole square. Okay, so this is R, sorry, I square RMS into R. So value of R is 1 ohm. So 32.80 we will get it as 1076 approximately watts. Okay, this is the power consumed by the resistor. So why only we are calculating for the resistor? Because inductor does not consume the power. Okay, it is a storing element. Next we will come to the power factor. Okay, I will rub this one. Okay, so we have to calculate the power factor. How do you calculate the power factor? It is nothing but cos phi. Cos phi will be equal to R by Z. So if you have to calculate this one, if you use this formula, it will be wrong. Okay, so that is because this is applicable for only one type of frequency, but we have got here multiple types of frequency. So this formula is not applicable for multiple frequencies. So then which formula we have to use? We also know that cos 5 is nothing but active power over S, that is apparent power. Okay, so we use this formula. We already know what is active power that we had calculated just now. Okay, so that was 1076 watts. Okay, that we have calculated from I square RMS into R. So now this S is nothing but apparent power. This can be written as VRMS into IRMS. We know what is the value of IRMS. So it is nothing but IRMS is 32.80. Okay, so but we do not know what is VRMS. We can calculate easily what is VRMS. So we have everything here. Okay, for all the three we know the voltages. So take under root, we have 5 square from the DC voltage. Okay, so this if you divide by root 2, it will get cancelled. Then 100 square plus similarly root 2 and root 2 will get cancelled. So you will get 10 square. So this is 25 plus 2, 3, 4, then 100. Okay, so this comes out to be VRMS is 100.62 volts. Okay, so substitute this one here, 1076 100.62 into 38.80. So you will get this power factor cos 5 as, so cos 5 comes out to be 0.32. Now tell me if it is lagging or leading. If you see the circuit, it is an RL circuit. Okay, so in RL circuit, due to the inductor, what it will be lagging. Okay, do not forget to write this lag or lead. Okay, so it is very much important. It indicates that it is an inductor. Due to the inductor, we are getting the lagging power factor. Okay, so in this question we have completed like solving all the important concepts covering for the superposition theorem. So first rule is that we have to convert the inductor or capacitor value into the ohmic value from Henry or Farad. Second is if you have got different frequencies, then you can solve that problem using superposition theorem only. Okay, so ammeter reading, it measures always RMS value. Okay, current RMS and voltmeter voltage RMS. So power, it is only consumed by the resistor. Okay, so you have to also know where to use power factor. If it is different frequencies, then you cannot use the R by Z formula. So this is applicable only for one type of frequency. So for that, having multiple frequency, we will use active upon apparent power. Okay, so we will see next, in the next lecture we will see the superposition theorem. It has got its limitations and also where it can be only superposition theorem can be used, and we have also seen that power will be having some exceptions. We cannot calculate power using superposition because we cannot add P1, P2, P3 in the deactivating one source and activating another source. Okay, so it has also got its exceptions. So we will see what are the exceptions in the next lecture. Okay, thank you.